Hello and welcome to this video on averages. While by no means is this your average video, it is all about the average. Of course, what an average is can be one of three distinct and separate things. Using them in the right way is important, but just as, if not more important, when you use them incorrectly. The most common concept of an average is if you take all the values of a sample set and add them together. Then you divide the total value by how many data points you have. As simply shown, it is summation over n, summation being the sum of all values, n being the number of values. Despite this perception, there are two others, the mode and median. Each is different and used for specific reasons. Let's start with mean, as it is the most common in people's minds, even if it is not always the right choice. Plus, it's perhaps the meanest of means. The mean is what you get by adding up all the numbers and dividing by how many numbers were in the list. Most people think of the mean when they use the word average in a mathematical sense. Think if you took all the students in the class and added together their height. Divide this by the number of students, and now you have the average height. And the mean is used for variables like this that are continuous. Generally speaking, it's going to be a numerical value. The problems with using the mean are not always obvious. You might think that is the best way, as it obviously shows the collective result, a democratic-like measure and outcome. The problem is that you have an average. That average can be drastically affected by outliers, or as you might more easily think of them, extremes. If you have a class of students and one student is a giant, the mean will be shifted by a commensurably big margin. That is because even if you divide the total, it still shows a big difference, as the difference between what would otherwise be the average and their height will gradually pull the dataset in their direction. Further, you have things like males and females. Males are generally taller than females. As a result, depending on whether or not there are more males or females in the dataset, it will artificially inflate or deflate that particular value, thereby altering the mean. This is where the next option can be useful, mode. A mode is the most common result. A mode is another word for most frequent or most, let's say, fashionable. It's the value where you can say everybody has this because it is the most common value. The shortcomings of the mode as an average are that they do not show a representative value of the sample set. They show you the most common sample value. By no means is this necessarily bad. For example, if you were trying to look at stocking something, you would consider what is the most frequently purchased thing, and you would buy more of that thing, and therefore it can have use in things like that. For example, if you were to order fast food, do people most frequently buy the small, medium, or large size? If the large size was the most frequently bought, you would stock up more on the large size, and then gradually less of the others. The shortcomings of a mode as an average is that it is not representative of the value of the sample set, but that doesn't mean it is without value as said. Now, you can take both the mode and the mean and use them together, and this is where they can become quite a powerful tool. Let's say you took the mean and mode and found two very different values. These two values can tell you a lot about the data that you're looking at. What we're working towards is if the data is skewed. Skewed refers to the way the data can be more or less biased to one side or the other of the bell curve. Or in some cases there's less of a curve and more of a hill side. That is, the data goes drastically up in one direction only, or there's a long tail. Generally speaking, if your data is skewed to the left, that means it's going to be focusing more towards the low end of the values. The mean is less than the median, and that will be less than the mode. If it's going to be skewed to the right, that is to say that the dataset is generally favoring larger values, you'll find that the mode is less than the median, which is in turn less than the mean. To be clear, this is shorthand and not necessarily perfect. There can and likely will always be exceptions to that rule, but it is a good guide. And now for the final application of averages, and we've already mentioned it, that being the median. This is a number you'll often hear thrown around regarding house prices. The median house price in X suburb is Y amount. The median is, in a sense, what you would, let's say, hear of when you think of somebody described as an average. It is the middle number. What you do when you get all of your values and you list them in order, that is from, say, smallest to biggest, fundamentally any systemized way, and you find the exact middle value. Much easier if it's an odd number data set because there's only one middle number, but in the case of there being two middle numbers, which you effectively have a tie, it's the difference between those two. It is by definition just the most middle number in the data set. Like with the mode, this is not always great, especially if data is very similar across a broad dataset. Take for example the number of wheels a car has. Most will be 4. This will then proceed if you are looking at motor vehicles to ignore motorbikes and trucks among many others. These would obviously be the, let's say, most frequent value, 4 being exactly in the middle, but you'd have, say, 6, 8 or even more on the high end, and 2, or if you wish to include unicycles, 1 on the low end. But since 4 is the most common, you would find that to be the median value. This is also why median averages can be flawed. They take the very broad data set and narrow down on a specific subset, and fundamentally ignore every other value in a way. To be clear, it can be useful if you want to examine the most common or frequent subset. It lets you do a lot. But it is important to be aware that they can be flawed. And now for how the three averages will overlap and why they work. The mean is good for the whole of data, but it will fail to highlight unique subsets or interest groups. At the same time, those unique subsets or interest groups can skew the results quite considerably. The mode is the most common, but most common fails to identify outliers or similar. Thankfully, it is less likely to be affected by those outliers. The median focuses on the middle point as though nothing else matters, and again, less affected by outliers, so it will tell you if there is something that is shifting your results if you consider all three at the same time. And that is why, if you use averages well, they can be very powerful. The data collected, the data type, the volume, and more will all affect why your analysis will be done in certain ways, and the average you focus on from that. Combining more than one average can also tell you about the data you collected. This is why the average is not always the right average. Of course, there are more advanced or complicated versions of what we've described, but for a beginning, knowing which is important, as too many make the mistake of using the wrong average or misunderstanding what it is. Consider, what if you were told the average person? You have to wonder, what sort of average are they talking about? The same thing if you're going to talk about an average income, an average car, an average house, or, in scientific terms, the average from a certain data set. It's really hard to get your head around what they mean by average without knowing what average they're referring to. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.